Hello there. So this is Data Science with Generative AI. This is the video core, and we are trying to see ChatGPT as an interactive tool for enhancing data analysis. So the problem statement, this is a kind of case study, is about the pregnancy risk evaluation using machine learning techniques. So we could ask, okay, can uh, how can how can ChatGPT be applied in clinical practice to improve the identification and management of risk during pregnancy? We fetch a data set from this reference here from Kaggle, and it was stated that the data was collected in several hospitals and maternal health clinics using advanced Internet of Things system in Bangladesh. So we are not going to be worried about the data quality. But this is not the original set. This is an adapt set. So this is adapt set from this set here. And so I began to say, okay, I have a data set about maternal health risk. I want to analyze it and use this data set for classification purpose. I will provide the data set. Which steps do you recommend regarding the data set analysis? With some typos, and it said, okay, great. The first thing is to understand the data set and doing some descriptive statistics. So this involves evaluating the mean, the median, the mode, the minimum max, standard deviation, and so on. And then he said, okay, check the data types. This was the first int. The second was to do a kind of exploratory data analysis with univariate analysis and bivariate analysis. So this involves to construct some histograms, some box plots, scatter plots, correlation matrix, and so on. And third, the feature engineering, which is like a transformation and new features. We spoke about that, this part in the previous video. And then, okay, data preprocessing and for model fitting. So, if necessary to convert the category data into numerical format, in this case, it's not going to be necessary. Split the database. This is important for machine learning. So we have to split the data in kind of training and testing sets. This is correct. And I'm going to explain in here that usually the set is split in a kind of training set and a test set. And the training set can also be subdivided in a training and validation set. Okay, so these are the normal way of doing training and validation and also test set. So model selection and training. Choose the model. Okay, he says that this is important. He says, okay, there is some logistic regression, decision trees, supporting vector machines, neural networks, and so on. So we have to choose. Then the cross validation, okay, to ensure that we don't have this problem of overfitting. Overfitting is a problem that can occur. It is stated here when, for instance, we don't have enough samples of the data, and the approximation function, for instance, using a neural network, memorize or overfits the data. So to avoid that, it's important to do this cross validation technique that we are not going to speak here with detail. And then step 7, model evaluation. You say, okay, use some performance metrics like accuracy, precision, recall, F1 score, calc to evaluate the classification model performance, and then do a confusion matrix. So these are some things also important to analyze the model results. Okay. And if you are not satisfied with the results, so iterate. So you have to repeat and go back and change some settings and so on. So I uploaded this spreadsheet data to the ChatGPT and said, okay, please help me doing the exploratory data analysis at ADA. And he says, okay, you have 817 samples. The columns are the first one for the age is between 15 and 49 for the women, systolic blood pressure, diastolic blood pressure, the third one, blood sugar, the four, the fifth is the body temperature, the sixth is the heart rate, and seven is risk level in three levels: high risk, mid risk, and low risk. Okay. Then he provided the median values, the mean values for the ages, which is this one, the blood for blood pressure, the ranges, and diastolic blood pressure, blood sugar, body temperature, and heart rate. So I asked it just to check to make an interval plots of the age between 15 and 19 years, 2024, 25 to 29, and so on until 49, just to compare. And really, this one are the most unrealistic one. But okay, it got 225 samples, and but the rest of those ranges are quite common for what I saw in the literature for Bangladesh. Okay. So these are also the distribution by age is in terms of samples, and you can see that the young is quite expressive here. And then I say, okay, let's proceed in some exploration steps and generating histograms and so on. And this guy say, yes, yes, please do help me. And so he begins to do a kind of histogram for the age and also for the systolic blood pressure, diastolic blood pressure, and so on. And one thing quite important that he provides the Python analysis scripts, so you can just copy this and run it for in your own environment. So this is very important for all the analysis that ChatGPT can provide, these Python scripts. And then it says, okay, some insights about the data. The age, it says, okay, it's a younger population with fewer older individuals. Systolic blood pressure, it says, is around 120, which is typical. Diastolic, it says, is around 70 and 80, also common for normal ranges. Blood sugar, okay, he says that probably is right skewed and he may have some high outliers. So this is a hint. The body temperature also it says in Fahrenheit says there's some higher temperatures. And their heart rate, it says, okay, that potential there's some outliers here as well and some errors. So, and then asking to provide some graphs regarding the distribution of age with the three risk levels, and also for the systolic blood pressure, diastolic blood pressure, blood sugar, and body temperature. In this one, I asked him to convert the Fahrenheit to Celsius the degrees, and he said, okay, as you can see, the majority of the body temperature measurements are centered around the normal human body temperature, which is 37 degrees. However, there are some measurements extending up to 39, as you can see here, some samples. And these indicate febrile conditions of some individuals. Some of these women were quite sick. So then the distribution of the heart rate. And okay, so great. We'll say, okay, let's do the correlation analysis. And I said, okay, we have three steps. First, the correlation matrix. Then we do a heat map visualization. And then third, the focus on the risk level. Then he started research. This is quite new in the ChatGPT. This is a kind of, I think this is associated with ChatGPT 4.5. He could could show you the steps that you were like doing in the reasoning, which is quite interesting. I'm not going to present that here. And then he said, okay, the correlation analysis of numerical features. He says he uses the Pearson correlation coefficients. The range are between -1 and 1. And so we have positive correlations are higher near 1 and negative are in near -1. So we could see some correlations here, strong correlations between the diastolic blood pressure and systolic blood pressure. And then moderate between the blood sugar and the age, moderate between the systolic blood pressure and age, and also between the diastolic blood pressure and age, and so on. There's also some here that you can see that also moderate, that I didn't mention, and also some negative ones. So the heat map visualization explains is going to divide in strong correlations, which are in this case were like the 0.77, moderate correlations in this range 0.3 and 0.5, and weak or no correlations. Okay. So this is the heat map that you can see here that he has constructed. And we can see that okay, the strong correlation is this one. And then he analyzes, and also you can see also check. And if you want the Python code, you just press this and you can copy it. And so we say some observations about the blood pressure. Okay, positive correlations, these ones, and then the Asian relationships or moderate correlations here. You can check as well, and so on. Blood sugar, heart rate. So in the end, he finally said, okay, the correlation with the risk level. He has divided this in three scales in low, mid, and high, and then he has provided some analysis between the blood sugar and the risk level, and also between the blood pressure and age between the risk level, and the heart rate and body temperature versus risk level. And he summarized really nice here. So overall, he shows us that the blood pressure and blood sugar are key predictors associated with the pregnancy risk level. Higher values of these are linked to the higher risk. Age, of course, is another factor which is noticeable through moderate correlation to the risk. I'll say older mothers tend to have higher risk. In contrast, both temperature and net rates show minimal correlation with the risk level. Okay, so this is quite a nice summary of the correlation analysis. So I asked him to do a kind of plots showing what are the feature importance for forecasting the risk, the pregnancy risk level. And you can see here that the most important is the blood, sugar, and then followed by the systolic blood pressure and the age, diastolic blood pressure, heart rate, and the less relevant is the body temperature. So next, I want to use some classifiers to forecast the pregnancy risk level. Which ones do you suggest? And he said random forest classifier is the first one, second one, random boost machines, third, support vector machines, four, logistical regression, fifth, K, nearest neighbors, sixth, neural networks, and seventh, naive Bayes. So a lot of models to machine learning models to forecast. You can use. We cannot test it all in this presentation, so I'm going to just to test some of them and two of them really. And he said, well, what are the steps? Okay, he has to do the processing, the model selection, the cross validation, the parameter tuning, and evaluation with those performance measures. Okay. So I said, okay, please do advance with the processing stage. And he said, okay, I'm going to check for missing values. No missing values. I am to try to encode the categoric values. There's no need. Feature scaling, I don't know if he has done this or not. And split the data as the way I explained. This is, he does that automatically, but you can ask what was the way he has done it, and we'll explain. So he said he has some results here, and you can also check the Python if you want, and say, okay. So let's start with the random forest one. That's the question that I made. And he said, okay, I'll train the model, I'll evaluate the model, and interpret the results. Okay, excellent. Let's do it. So these are the results in terms of the precision, recall, and F1 score. You can see that are quite high values for the low risk, also for the mid risk, and are excellent values for the high risk. So this is like probably not one, it's 0.95, but even so, they are really, really high, which indicates that this model performs quite well in this problem. Once more, you say, okay, if you need some adjustments, and also the Python is here. You can see also the results in terms of a confusion matrix, and you see here that these are the right predictions and some wrong ones, indicating what you can do. And then also in these rock curves, can see that the values are quite high, 0.95, 91, and 99. So these are really good values. So the next model I said, okay, please try gradient boosted machines, GVM, sorry, and he is going to use this package. And these are the results. Okay, also high, as you can see here in the terms of the precision, recall, and F1 score. and also these are quite high. So we're asking to compare the two. Oh, sorry, before I ask you to do also the confusion matrix and the rock curves, and finally a comparison between the two. And you can see that there's not a big difference. They are very similar. For instance, this one is the same value. Gradient boosting is better here, but just slightly. So really, the values are really similar. So the performance comparison between the gradient boosting machine and the random forest are quite similar in terms of performance. But of course, you try like neural networks, another one, logistic regression, you'll see that the difference are wider. So with this, okay, so these are the insights of the comparison, okay. And okay, with this